Hello all, welcome to the World of Physics YouTube channel. My name is Travis and I'll be creating a series of videos in order to help you all better understand this wonderful and majestic world of physics. In today's video, I'll be giving a brief overview of what content these videos will contain and a brief overview of what physics is. So let's begin, shall we? Physics. What is it? Is it the governing laws of this world? Or is it simply how things work? Well, to answer that question, it's kind of both. Physics is a branch of science concerned with the nature and properties of matter and energy. Physics includes mechanics, heat, light and other radiation, sound, electricity, and the structure of atoms. So to sum up, physics is a study of matter, its motion and behavior through space and time. Overall, the main goal of physics, though, is to understand the natural phenomena of how the universe behaves and what our part is within it. So, now that you know what physics is, let's talk about it. I'll be talking about in each video. In today's video, we'll be talking about waves, their nature and their properties. In the next video, we'll be talking about the conduction of electricity and resistance. Two other topics I'll be talking about are stars and planets and the understanding the many equations along with SI units and multipliers. There's something very big that's noticeable. It has lots upon lots of many different equations that many very well known and very smart scientists have come up with. And overall, it's understanding the in-depth of how things actually work the way that they do. Well, now we have all that introduction out of the way, let's go into the topic itself. Waves. What are they? Waves transfer energy from one place to another. Wherever there is a wave motion, there must be a source of oscillation and a material or field which can transmit oscillations. Moving waves are called progressive waves. This can be shown using a slinky. Waves are represented as two different types. You have transverse waves and longitudinal waves. For a transverse wave, the oscillations are at right angles to propagation of the wave. Example would be electromagnetic waves. The direction of propagation is simply the direction in which energy is being transferred along the wave. For a longitudinal wave, however, the oscillations are parallel to the propagation of the wave, such as sound waves. All waves can be represented as one of two ways on a graph. Either a displacement time graph or a displacement distance graph. You will hear me say a couple of words that you might not have understood. So let's go for those, shall we? Here's some definitions. An oscillation is a regular, repeated motion about a central value on a wave. Displacement is the distance of a point on a wave from its equilibrium position. Equilibrium is the point on a wave that stays constant all throughout the wave. Wavelength, or also known as lambda, is the minimum distance between 2 points that are in phase on a wave. Amplitude is max displacement from its equilibrium. Max displacement of a particle from its equilibrium position. Frequency is the number of full cycles of a wave that pass a fixed point in a singular second. And then time period is the time taken for one complete cycle of operations. And finally, phase is the angle or time by which one wave leads or lags another. Now, let's talk about intensity. From a point source, the energy in intensity and waves moves outwards in three dimensions. This means that the wavefronts are spherical. The equation to find intensity is known as power divided by area, or, because it's from a point source, power over 4 pi r squared. Intensity tells us that if the radius from the point source increases, then the energy the waves carry is spread over a larger surface area. Now, let us move on to phase. When particles are in phase, they are at the same point in an oscillation cycle at the same time. Now, normally we would use degrees as the units of angle, correct? However, there are other units that we can use. Another unit that can be used is known as radians. 360 degrees is equivalent to 2 pi radians. 270 degrees is 1.5 pi radians. 180 degrees is 1 pi radians. And 90 degrees is 0.5 pi radians. Now, that's basically sums up phase. So, let's talk about polarization. Only transverse waves can be polarized to start off. That is a definitive fact. If the oscillations take place in just one plane, well then the wave is said to be plane polarized. Unpolarized light waves can be polarized using a polarizer, such as a sheet of Polaroid. The Polaroid allows waves with vibrations in one single plane to pass through the sheet, to absorb all the waves which are at right angles to this plane. The fact that light waves can be polarized is direct proof that they are transverse, because longitudinal waves, such as sound waves, cannot be polarized since their vibrations parallel to the propagation, or the direction in which a wave is moving. When light is reflected off a surface, it is known as partially plane polarized. So, well, that just about sums up the nature of waves, I guess. So let us move on to wave properties. To start understanding the properties of waves, we first need to understand how waves look and act. However, we now know this as we've gone through the nature of waves. So, let's start with diffraction, shall we? What is it? Well, simply, diffraction is the spreading out of a wave around an obstacle or edges of a slit. The extent to which waves spread out depends upon the wavelength of the waves and the size of the slit or aperture. Diffraction is more noticeable if a gap is approximately the same size as the wavelength of a wave. Simply put, when a wave passes through a gap, it diffracts, and if we put a screen opposite to the slit that is diffracting from, then we can see the effect of this diffraction. If a slit width is less than or equal to the wavelength, then the wave spreads right around through almost 180 degrees, forming semicircular wavefronts. However, if the slit width is greater than the wavelength, then there is a main central beam which spreads through less than 180 degrees. Also, there are side beams of much lower amplitude, as seen in the diffraction of the water waves on this diagram. So that's diffraction. Now let's look at interference. With waves through diffraction, interference occurs when two or more waves combine to produce a resultant new wave. If your waves combine to produce a resultant wave with a higher amplitude, then the originals are said to have interfered constructively. If, however, the resultant wave has a smaller amplitude, then the waves are said to have interfered destructively. So to sum that up, interference is when two or more waves combine to produce a new wave. If that resultant wave has a higher amplitude than the originals, then the interference to get the resultant wave was constructive. However, if the interference between the waves creates a new wave with a smaller amplitude, then the interference pattern was destructive. Constructive and destructive interference are examples of the principle of superposition. The principle of superposition states that when two or more waves travel through the same region at the same time, the resultant displacement at any point is the vector sum of the displacements of the individual waves. To produce an observable interference pattern, two sources must have similar amplitude and be coherent. Coherent waves have the same frequency or wavelength, and their phase relationship does not change. There is a very famous experiment within physics to show diffraction. This experiment is called Young's double slit experiment. Thomas Young's experiment in 1801 was one of the most significant pieces of evidence to support the wave theory of light. Before Young's interference experiment, most scientists accepted Newton's view that light was a stream of particles. Now that we know about diffraction and Young's double slit experiment, let's move on to diffraction grating. The equation for diffraction grating is as follows. d sine theta equals n lambda, where d is slit separation, theta is the angular direction in which constructive interference is taking place, and n is the number of maximum. For example, When n equals 1, this is called the first order maximum. So that's diffraction rating. So we'll now move on to stationary waves. And that will be end of wave properties. Stationary waves. Under certain circumstances, it is possible to create a motion which oscillates like a wave, but the positions of its peaks and troughs do not change. Waves like this are called standing or stationary waves, and are a special case of interference. When two progressive waves of the same frequency and amplitude, which individually would be traveling in opposite directions, occupy the same region, interfere, they produce what's known as a stationary wave. So what's the difference between a progressive and a stationary wave? Well, to start off, progressive waves transfer energy, while stationary waves do not. In a progressive wave, all the particles have the same amplitude. In a stationary wave, from node to antinode, the amplitude varies depending upon the position of a particle. And lastly, in a progressive wave, along one wavelength, there is a phase difference between all the particles, whereas in a stationary wave, all the particles between two adjacent nodes are vibrating in phase. There is a phase reversal at each node. So, that just about sums up wave properties, which in turn sums up everything I've talked about with waves in this video, their nature and their properties. So, I know this video has had a wide range of information for you to take in. I hope that this information has helped you to better understand waves. All this information is at A-level physics. If you were to pursue a lot more and more in depth at higher degrees of learning. But anyway, I hope that you thoroughly enjoyed watching this video, and perhaps it will begin a spark in you to pursue this wonderful world of physics. Anyway, if you did enjoy, then please let me know what parts you enjoyed, and what parts you feel could be better explained. So please let me know so I can read you all enjoyed and learn something new potentially. Well, that'll be it for me today. I hope to see you all next time. Goodbye.